I'll be focusing on are large igneous provinces. As implied by their name, these are massive sections of basalt, which is the standard volcanic rock, and they can cover millions of square kilometers potentially and occupy thousands, possibly hundreds of thousands of cubic kilometers. They can occur in all areas of the globe independently of fault regions. They're given different names depending on where they are in reference to continents and oceans. Volcanic passive margins are on the borders between oceans and continents. Oceanic plateaus are entirely submerged beneath the ocean, and continental flood basalts are entirely on land. So they are formed when a hotspot occurs on the surface. Hotspots are born from massive mantle plumes, which are essentially very high temperature, low viscosity plumes of molten rock that rise up from the D layer, or the layer dividing the outer core and inner mantle, and they impact the crust. These formations take, on average, about 1 million years to occur, as best we can tell. In comparison, the Rocky Mountains, a significantly smaller geologic formation, have been rising for 40 million years. So these are extraordinarily massive events, and they take place in very short periods of time. So the large igneous province, or that I'll be focusing on today, are the Deccan Traps. These are located in western India, and when they were finished forming, they most likely occupied around 2 million cubic kilometers. That's just solid rock that erupted from this one place. And lava often contains iron titanium oxides that align to the Earth's magnetic field when the substance is there and hardens. And using a field called magnetostratigraphy, we can determine the age of these things when they have iron titanium oxides present, which allows us to date the Deccan Traps to within 1 million years of 65 million years ago. So that establishes that it took place very near to the extinction event. Late Cretaceous sediment, I'm not entirely certain how to pronounce the field there, but Maastrichtian, I believe. And sediment found underneath flows and directly inside of them coincides with that period, which is 500,000 years around the extinction event, and we believe the Deccan Traps were erupting off and on during the entirety of that period. So iridium found in the KT boundary layer could easily have been produced not by an impact event, but by the Deccan Traps eruption. Iridium is very prevalent in the mantle, and evidence from volcanic eruptions that occur all the time show that volcanoes can very easily produce iridium. Smectite, a type of clay that occurs in the KT boundary, can in fact be produced by altering volcanic ash through a very simple process. So that's that. The basaltic spherules that have been found throughout the KT boundary, and especially around, could have been produced by volcanic convecta as opposed to being produced in an impact event. Shock quartz, something that's often considered the best evidence for the impact event, could have been produced by volcanism as well. At very high temperatures, it takes far less pressure to produce this effect in quartz. High temperatures are obviously going to be produced by volcanism, and gases within the Earth's crust that would be released from this vent would provide the necessary pressure. In addition, the Columbia River, Kerguelen Plateau, and Siberian Traps, these are all separate large igneous provinces that correlate with other mass extinctions in the past. The Siberian Traps especially, they've been dated and are believed to be the probable cause of the Permian extinction. So there's a definite precedent for large igneous provinces. In conclusion, this event would be on a scale we've never really seen before, and would most definitely be capable of producing effects that we've seen in the KT boundary layer. Ejecta reaching the stratosphere would distribute iridium all over the globe, sulfur oxides, acid rain, and would produce effects actually very similar to that which would be caused by an impact event. However, there is far more evidence for this.
2 minutes. slide that this stuff happened all around the globe. Can you give any specific locations other than the Deccan Flats or Traps?
I'm not sure what you're asking.
I'm asking that, let me ask you a different question then. How can just one super volcano or whatever you're talking about, kill everything in the world? I'll answer this.
Do you want me to answer
Yes, I
that?
want you to answer that.
No? Okay.
Okay,
I will answer.
1 minute.
okay.
Happily, actually.
No, okay, how? No, so would it be possible that, the iridium fell in the thing, could be, what am I saying? How is it possible that the Deccan Trap iridium is found all over the world?
Because the volcano would easily be capable of spreading it. I mean, the smoke plume of this event would be extraordinarily massive. It would go on for hundreds of thousands of years off and on. And so that would spread it over a large area, including Asia, possibly Africa, and most definitely India. And the plume would also be high enough to reach stratospheric winds that would blow it all over the rest of the globe. And there would most definitely be enough to cover the entirety of the world.
So, is there evidence, like, in other volcanic eruptions that, like, is there iridium found in those boundaries as well?
Yes.
So how would you explain that the iridium is 30 times, the concentration of iridium is 30 times greater at the KT boundary?
The amount of iridium found in the KT boundary correlates with the amount that we predict would be put out by this event.
Can you explain the 18 amino acids referenced by the pro side, that they claimed were only found in asteroids that were also found in the KT boundary?
It's definitely not my field of expertise. However, I'm not really sure how to answer that. There are, however, many things that exist not on the Earth's crust that are definitely present in the mantle that we don't fully understand. We certainly haven't cataloged all of them. The iridium is a prime example there. It doesn't exist on the crust in any large amounts, but it does in the mantle. So I'm not saying it definitely was produced there, but it may have been.
I think what Dan was trying to ask was if if it was only the Deccan Traps that were exploding volcanoes during the KT era, and how that would have been able to, how only those certain traps would be able to wipe out all of dinosaurs as well as other species.
Well, the Deccan Traps were the only major volcanic event happening at the time. It's the same sort of logic that supports the impact theory. It is definitely a single event in one specific location, however, it's so ridiculously massive that it would easily spread debris over the entire globe. The scale of this volcanism is just beyond human imagination. It would most likely put out 1 to 2 cubic kilometers of rock on average per year. That outstrips, that's a lot. That outstrips anything that we've ever experienced. I mean, even like Krakatoa, again, like the Icelandic volcano that happened earlier, completely shut down air travel in Europe. I mean, just that one volcano that would be minuscule in comparison to this, shut down